Solutions of MHT-CET 2018. So question number 1, solution given problem 0 to k 1 upon 2 plus 18x squared dx is equal to pi upon 24. Then the value of k we want to find out. So we have to common 18 from the given problem, then 1 upon 2 by 18 plus x squared, which is pi upon 24. So 1 upon 18, 0 to k, it is 1 by 9, can be taken as 1 by 3 whole square plus x square dx, which is equal to pi upon 24. It is in the form of 1 upon a square plus x square. This formula is 1 upon a tan inverse x by a, that is x upon a is 1 upon 3. It can be equal to pi upon 24. Now we have this 3 6 times cancel and 6 4 times cancel. Then tan inverse 3x whose limits 0 to k is equal to pi upon 4. Then tan inverse upper limit 3k minus lower limit x is equal to 0 you substitute, then pi by 4. So tan inverse of 3k minus tan inverse of 0 is 0, which is equal to pi by 4. Then tan inverse 3k is equal to pi by 4 and 3k is equal to tan 45 when we take tan this side. So 3k is equal to tan 45 is 1 and k is equal to 1 upon 3. So from our options the answer is C. Now the question number 2, solution is the Cartesian coordinates of the point on the parabola y square is equal to minus 16x whose parameter is 1 by 2. Then points we want to find out. So given parabola y square is equal to minus 16x. Next, the point on the parabola parametric form is at square comma 2at, be a point on the parabola, and from the parabola 4a is equal to minus 16, then a is equal to minus 4. Now we want to find out this point where given t is equal to 1 upon 2 and a is equal to minus 4. Therefore the point is at square comma 2at can be taken as a is minus 4, t is 1 by 2 whole square, 2 into a is minus 4 and t is 1 by 2. Now what are getting here, minus 4 into 1 by 4. Similarly here 2 get cancelled, minus 4. Now here 4 will be get cancelled, minus 1 comma minus 4 be our option. So from the options the answer is C. Now the solution, question number 3. So here the problem is given integration of 1 upon sin x into cos square x dx. Now we have to solve this. Here we have the numerator 1 can be taken as identity, that is sine square x plus cos square x upon already sin x cos square x is in the denominator. Now we are separating sin square x upon sine into cos square with the one integration, and another one is cos square x upon sine into cos square with another. So integration of 1 upon cos secant x sine upon cos tan x plus here integration of 1 upon sine cosecant x dx. So integration of secant x tan x is secant x, and integration of cosecant x, that is log of cosecant minus cot x plus c. So answer D. The question number 4 solution is log of to the base 10, the given problem, x cube minus y cube upon x cube plus y cube is equal to 2. Now you find out its derivative, dy by dx. Now the base 10 you get that side, then x cube minus y cube upon x cube plus y cube, then it becomes 10 square. X cube minus y cube is equal to 100 into x cube plus y cube by cross multiplication. Now you multiply, then x cube minus y cube, here 100 x cube plus 100 y cube. Now you take one side, x cube is this side and y cube is here. So 100 we are getting this side, minus 100 y cube minus y cube. Here x cube you take this side, 100 x cube minus x cube. This is minus 101 y cube. Here 100 minus 1, 99 x cube. Now we have to differentiate. We want to find out dy by dx. So minus 101 y cube का derivative 3y square dy by dx. There 99 into 3x square. Now both sides, the 3 will be get cancelled, and dy by dx is equal to what you are getting, 99x square upon 101 y square with minus. You take this minus this side. Now the dy by dx we want in only x and y. So for that dy by dx is equal to, now see here, from this 99 upon 101, this equation you take as a 1 from 1. The minus 99 upon 101 can be taken as y cube upon x cube. Okay, from this first equation we take this minus 99 upon 101 equal to y cube by x cube. Now here you substitute, then y cube upon x cube into x square upon y square. Then here y square get cancelled, x square get cancelled. Therefore dy by dx is equal to y upon x. Now we see the options. D be our option. Answer D. So solution 5. Given function f of x is equal to x square minus 4 upon x minus 2. Then it can be taken as x minus 2 into x plus 2. Already upon x minus 2 is there. So x minus 2 will be get cancelled. Then f of x is equal to x plus 2. But x belongs to the domain. X belongs to r minus 2. Therefore, the range of f of x is total real numbers except 4. Since x is equal to 2, then f of x is equal to 2 plus 2, 4. Therefore, by our options, the answer is C. Now the solution 6. So given problem, f of x equal to x square plus alpha 2 into root over x square plus 1 plus beta is continuous, and f of 1 by 2 is equal to 2, then alpha square plus beta square. So f of x is continuous at x is equal to 0. Then we know इसका left hand limit is equal to right hand limit, which is equal to function value. So left hand limit extends to 0 minus. So 0 minus, what is the function will be there? Less than 0. 2 into root over x square plus 1 plus beta. RHL limit extends to 0 plus. Here the function is x greater than 0, x square plus alpha, and f of 0. For f of 0, here x equal to 0, the function is x square plus alpha. In place of x, 0 square plus alpha. Now you substitute the limit value, then 2 into root over x equal to 0, 1 plus beta. Here x equal to 0 plus alpha and again alpha. So 2 plus beta is equal to, for both same alpha I am taking 1. Then you get one condition, alpha minus beta is equal to 2. This is the equation 1. Now given f of 1 by 2 is equal to 2. The 1 by 2 belongs to function is first function x square plus alpha. So f of x is equal to x square plus alpha, and in place of x you substitute 1 by 2, then 1 by 2 whole square plus alpha is equal to 2. Now 1 by 4, you take that side, 2 minus 1 by 4, then alpha is equal to 4 into 2, 8 minus 1, 7 upon 4. Now from first equation, alpha 7 by 4 minus beta is equal to 2. So beta is equal to 7 by 4 minus 2. So beta is equal to 7 minus 8 minus 1 upon 4. Therefore, alpha square plus beta square is equal to alpha 7 by 4 whole square beta minus 1 by 4 whole square. So 49 upon 16 and 1 upon 16, that is 50 upon 16. It can be cancelled by 2 25s are and 2 8s are. Then our option is 25 upon 8, that is C. Now the question number 7, whose solution? The given y equal to tan inverse x whole square. Now we have to find out this value. So given function y is equal to tan inverse x whole square. Okay, now we are differentiating with respect to x. Then dy by dx is equal to 2 into tan inverse x. Okay, we take an x square form, 2 into x. Here tan inverse x inner derivative, that is 1 upon 1 plus x square. Now we are cross multiplication this 1 plus x square this side, then plus x square dy by dx is equal to 2 into tan inverse x. Now again we are differentiating. Before differentiate, you give the numbers. This is the 1, and after differentiating, this is the 2. Now again we are differentiating. It is in the form of uv. So if we are applying formula, first function u same as it is, second function dy by dx derivative d square y by dx square, plus first function 1 plus x square derivative 2x, and second function is same as it is. Now it can be taken as 2 into derivative of tan inverse 1 by 1 plus x square. Now this 1 plus x square we are getting cross multiplication, multiplied, then 1 plus x square whole square d square y by dx square, plus 2x you multiplied by 1 plus x square into dy by dx. Now what is the remaining we have in RHS? 2. So our option is B. Now the solution of 8. The line 5x plus y minus 1 is equal to 0 is coincide with one of the lines. Then the value of k means this line be the any one of the line of this pair of lines. Now substitute in this, what we have from given line 5x plus y minus 1 is equal to 0, y is equal to what we have minus 5x plus 1. Substitute in the pair. What is the pair of lines? 5x square plus x into y. Y is minus 5x plus 1 minus kx minus 2 into y. Y is minus 5x plus 1 plus 2 is equal to 0. Now simplify this. Here 5x square minus 5x square plus x minus kx minus of minus plus 10x minus 2 plus 2 is equal to 0. Now here 2 will be get cancelled. 5x square is also get cancelled. Then here 10 plus 1 11x minus kx is equal to 0. Then x getting common, so 11 minus k is equal to 0. Now x is equal to 0 and 11 minus k is equal to 0. Now we want to find out k value, then k is equal to 11. Then from our options the answer is C. Now the solution of question 9. So A is equal to the matrix will be given 3 by 3. Now then you find out A square minus 5A multiplied by A inverse. Now you multiplied with this A square into A inverse minus 5 into A inverse. Then A power become 2 minus 1 A minus 5 into A into A inverse is identity. Now A matrix will be given, that is 1 2 3 minus 1 1 2 1 2 4 minus 5 into identity of 3 by 3 is 1 0 0 0 1 0 0 0 1. Now from this matrix A 1 2 3 minus 1 1 2 1 2 4, we subtract the second matrix, we multiplied by 5 inside, 5 0 0 0 5 0 0 0 5, or we see about only first row, 1 minus 5 minus 4 2 minus 0 and 3 minus 0 is 3. Similarly second row, minus 1 minus 0 1 minus 5 and 2 minus 0, 1 minus 0 and 2 minus 0 is 2 and 4 minus 5. Now you observe from our options, the answer is B, minus 4 2 3 minus 1 minus 4 2 1 2 minus 1. Okay. Solution of question 10. The given problem, the equation of line passing through 3 minus 1 2 and perpendicular to the lines, passing through the point given that 3 minus 1 2 and perpendicular to the lines given r bar is equal to, first line I plus j minus k plus lambda into 2i minus 2j plus k. Second line r bar equal to 2i plus j minus 3k plus mu into I minus 2j plus 2k. Now the line is perpendicular to these two given lines, then its normal DRS is also perpendicular to these DRS. What do you have? The DRS of required line, DRS of required line, we are getting from these two vectors, 2i minus 2j plus k and I minus 2j plus 2k by cross multiplication method, that is minus 2, next k coefficient 1 and here I coefficient is 2, here j coefficient is minus 2. Similarly from second vector, j coefficient minus 2, here 2 and here I coefficient is 1 and here it is minus 2, and we take the normal DRS is, it is A, B, C. So A upon this determinant we are finding, minus 2 into 2, minus 4 minus of minus 2, that is plus 2. Similarly B upon 1 upon 1 minus 4. Similarly C upon minus 4 minus of minus plus 2. So DRS of required line, DRS of our required line is minus 4 plus 2 minus 2 and 1 minus 4 minus 3 minus 4 plus 2, that is minus 2, or we take common minus, then 2 3 2. The line passing through the point is 3 minus 1 2. Passing through the point is 3 minus 1 2. Then the line equation is x minus 3 upon the DRS, y minus of minus plus 1 upon DRS, z minus z1, that is 2 upon DRS. So the required line from the options is x minus 3 by 2, y plus 1 by 3 and z minus 2 by 2 is option C. Now the solution of question number 11. The solution is the letters in the word Hululu are rearranged. The word is H U L U L U L U. Given what? The probability of all three L being together. Okay, so probability of probability of any given problem we are finding by what? It's a sample space n of s. N of s is this word can be arranged 1 2 3 4 5 6 7 8. 8 letters can be arranged in 8 factorial ways upon here u 1 2 3 4. The u comes 4 times and L 1 2 3. The L comes 3 ways. So this u 4 times can be arranged in 4 factorial. L can be arranged in 3 factorial. Now the given condition is the probability of all three L being together. Now L being together, you take L as together as a one letter and remaining letters H only one and U's are 4. 1, 2, 3, 4. Now how many letters are there? 1, 2, 3, 4, 5, 6. So N of E means the condition for all three letters come together, number of ways. So total letters 1, 2, 3, 4, 5, 6 can be arranged in 6 factorial. In this, how many repeated? U's are 4 times repeated, that is 4 factorial. Okay, so probability of this event is equal to N of E upon N of S. N of E is 8 factorial by 4 factorial into 3 factorial and N of S is 8 factorial by 4 factorial 3 factorial and N of E is 6 factorial by 4 factorial. N of E is equal to 6 factorial by 4 factorial and N of S 8 factorial by 4 factorial into 3 factorial. Now 4 factorial will be get cancelled. Now 6 factorial is same as it is. This 3 factorial comes to numerator and denominator 8 factorial you take as a 8 into 7 into 6 factorial decreasing up to 6. Then both the 6 factorial will be get cancelled. Now the value is 3 factorial which is 6, 3 into 2 and upon 8 into 7. It will be cancelled by 2 3s are here, 2 4s are, that is 3 upon 28. Now from our given options, this is option C. The solution of question number 12. So the sum of first 10 terms of the series. The given series is 9, 99, 999 and so on 10 terms. Now this S can be taken as 9 can be taken as 10 minus 1. Next 99 can be taken as 10 square, 100 minus 1. Now 10 cube minus 1 and so on 10 terms. So now separate the 10 terms. First term 10, 10 square, 10 cube and so on up to 10 terms. Minus of 1 can be taken as 1, 1 also 10 times. So this 10 plus 10 square plus 10 cube, it is in GP. So here it is in GP where A is equal to 10 first term and common ratio R is equal to 10, number of terms N is equal to 10. Now sum of terms is A into 1 minus R. R means 10 power N. N means what here? 10 by 1 minus R. R means 10. Now minus here 1 1 1. 10 times we are adding, we are getting 10. Then S is equal to 10 here 10 raised to 10 minus 1 upon, here we minus getting common, 10 minus 1 minus 10. So S is equal to 10 into 10 raised to 10 minus 1 upon 9 minus 10. Now we have to simplify, then 10 into 10 raised to 10 multiplied in this minus 1 into 10 minus 9 into 10 upon what? 9. Okay, now S is equal to 10 into 10 power 1 plus 10, it is 11. Here minus 10 minus 90, 100 can be taken as 10 square upon 9. Now in both we are getting common 10 square. So in 11 we are getting 2 common, then it is 10 raised to 9 minus 10 square already getting common, it is 1 upon 9. This is our sum of 10 terms. Now the option is hundred upon 9 into 10 raised to 9 minus 1. So the option is B. Solution of question number 13. So given problem, if ABC are the angles of triangle ABC, then cot A cot B plus cot B cot C plus cot C cot A is equal to. In triangle ABC, we know that A plus B plus C is equal to 180 degrees, or A plus B is equal to 180 minus C. When we say it, we take this side. Apply cot on both sides. Cot of A plus B is equal to cot 180 minus C. Cot A plus B formula is cot A cot B minus 1 upon cot B plus cot A, and cot at 180 it become minus cot C. So cot A into cot B minus 1, this cross multiplication, minus cot C multiplied by cot B plus cot A. So cot A cot B, here minus cot B cot C, you take this side, minus cot B cot C, multiply, you take this side, cot B into cot C. Now cot C into cot A, you take this side, plus cot C into cot A. Now this minus 1, you take this side, it become plus 1. So by our options, our answer is 1. So solution of question number 14. So integration of 1 by root over 16 minus 9x square dx is equal to a into sine inverse bx plus c, then find a plus b. So this integration we are getting common 16 outside, it becomes 4. So 1 minus 9 upon 16 x square dx. So 1 upon 4, it can be taken as 1 minus 3 by 4x whole square dx. So 1 by 4, here integration is 1 by root over 1 minus x square, that is sine inverse x. But in place of x, we have 3 by 4 x, uska inner derivative 3 upon 4 plus c, and it can be taken as is equal to here a sine inverse bx, a sine inverse bx plus c. Now here the 4 will be get cancelled, and a is 1 upon 3 sine inverse 3 by 4 into x, here a into sine inverse bx. From our options we want to find out a plus b, then a is equal to 1 upon 3 here, and b is equal to 3 by 4. Therefore a plus b can be taken as 1 upon 3 plus 3 upon 4, taking LCM here 4 times, here 3 into 3 9, which is equal to 13 upon 12. So our option is D. The solution of question number 15. So the given problem, e power x into 2 plus sine 2x upon 1 plus cos 2x dx. Now this problem we have to change into e power x into f of x plus f dash form. This can be taken as e power x into f of x. So e power x into, solving this, 2 plus sine 2x can be taken as 2 sine x into cos x, and similarly 1 plus cos 2x can be taken as the formula 2 cos square theta. Here 2x will be there, here we are getting x. Now e power x into, here numerator 2 we are getting common, so 1 plus sine x into cos x upon 2 cos square x dx. Now 2 will be get cancelled, then e power x into 1 upon cos square secant square x and sine upon cos, and 1 cos will be get cancelled if you separate, sine into cos upon cos square, 1 cos will be get cancelled, then e power x into, here sine by cos you take as tan, and secant square same as it is. Now by our formula, well known formula, we take e power x into, this is f of x, it is f dash of x, then what we are getting, e power x into tan x plus secant square x dx can be taken as e power x into f of x, that is our tan x plus c. So by given options we have a option. The solution of question number 16. It is given that A coin is tossed 3 times. If x denotes the absolute difference between the number of heads and the number of tails, then p of x equal to 1. Now coin tossed 3 times. Coin tossed 3 times, then we know n of s, number of sample spaces, number of possible chances for one coin 2 ways, for 3 coins 2 cube, that is 8 ways, n of s. And n of e, n of e means here the difference between the number of heads and the number of tails we want to find out. So here x is equal to capital X be the difference between capital X, difference between heads and tails. So the possible values are x is equal to 8 ways or h, t, 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 h, t, similarly t, 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 all t's, or 1 h, h, t, h, t, h, total 1, 2, 3, 4, 5, 6, and another way is t, t, h, and another way is t, h, h. These are the number of ways. So for 3 h's, the difference is 3 heads, 0 tails. This is 3. Similarly, for 2 heads, 1 tail. So 2 head, 1 tail, the difference is 1. Similarly, we have THT, the difference is 2 tails, 1 head, the difference is 1. For triple T, so 3 minus 0, which is equal to 3. HHT, we have 2 minus 1, which is 1. Similarly, HTH, 2 heads, 1 tail, so difference is 1. TTH, the difference for 2 tails, 1 head, 1. Similarly, THH, 2 heads, 1 tail, 1. So number of ways, n of e is equal to total 6, therefore probability of this event is n of e 6, and n of s is 8. That is 2, 3, 2, 4, and the option is 3 upon 4, that is D be the option. The solution of question number 17. The given problem, 2 into sine of theta plus pi by 3 is equal to cos of theta minus pi by 6. Then you find out tan theta. Now we are applying our formula sine of a plus b, that is sine a cos b plus cos a sine b, which is equal to cos of a minus b, cos a cos b, b means pi by 6, plus sine a sine b, b is pi by 6. So 2 into sine theta cos pi by 3 cos 60, that is 1 by 2, plus cos theta sin pi by 3 sin 60, that is root 3 by 2, which is equal to cos theta cos pi by 6 30, that is root 3 by 2, plus sin theta sine 30, which is 1 by 2. Now we simplified. So here 2 will be get cancelled inside sine theta. Here 2 will be get cancelled root 3 cos theta. Here root 3 by 2 cos theta plus 1 by 2 sine theta. Now you take sine theta this side. So sine theta minus 1 by 2 sine theta cos theta on another side, root 3 by 2 cos theta minus root 3 cos theta. So 2 sine theta minus 1 sine theta, that is sine theta by 2. Here root 3 cos theta minus 2 root 3 cos theta upon 2. Now both sides 2 will be get cancelled. Then sine theta is equal to 1 root 3 minus 2 root 3, that is minus root 3 cos theta. Then sine theta upon cos theta is equal to minus root 3, that is tan theta is equal to minus root 3. Now from our options, tan theta value is minus root 3. The option is D. Now the solution of question number 18. The area of the region bounded by x square is equal to 4y, the upward parabola, and the lines y is equal to 1, y is equal to 4, and the y-axis. So lying in the first quadrant. By diagram we have, this is upward parabola, and y is equal to 1 be the line parallel to x-axis, y is equal to 4 be the line which is also parallel to x-axis, and y-axis is this. Now we find out this area. Okay, now from this x is equal to the x square value is become 2 into root y. Okay, now y limits are y is equal to 1 and y is equal to 4. Between the area with respect to this curve we want to find out. So required area is equal to the limits of y are 1 to 4. And the curve is x is equal to 2 root y dy. Now we are integrating 2 into, this is y raised to 1 by 2. Its integration is y power 3 by 2 upon 3 by 2, whose limits are 1 to 4. Now here this 2 comes to numerator. Okay, 4 by 3 into y raised to 3 by 2, whose limits are 1 to 4. Now substitute the limits. 4 by 3 upper limit, 4 can be substituted in place of y equal to 4 can be taken as 2 square whole power 3 by 2 minus y is equal to 1 be the lower limit whole power 3 by 2. So this 2 will be get cancelled. Now 4 by 3 into, this is 2 cube 8 minus this is 1, which is 7 into 4 28 upon 3 square units. So the required option is B. So the solution of question number 19. given f of x is equal to e raised to x square minus cos x upon x square. Now it is continuous at x equal to 0, then find f of 0. So f of x is continuous at x is equal to 0, then limit x tends to 0, f of x is equal to f of 0 by continuous definition. So limit x tends to 0, f of x is e power x square minus cos x upon x square is equal to f of 0. So limit x tends to 0, subtracting 1 from e power x square and adding 1 minus cos x upon x square we are separately divided, which is equal to f of 0. So limit x tends to 0, here e power x minus 1 upon x, the value is 1, and 1 minus cos x, separately you find out the limit. X tends to 0, 1 minus cos x can be taken as 2 sine square x by 2 upon x square, which is equal to f of 0. So limit x tends to 0, the first value is 1 by well-known formula, and here 2 into limit x tends to 0 sine x by 2, okay, upon here x by 2 whole square we want in the form of square. So sine square x by 2 is in the numerator, here x square by 2 we want, 2 square 4 you are multiplying, and here we have to divide, 4 say multiply, 4 say divide, which is equal to f of 0. So limit x tends to 0, 1 plus 2 into this limit value is 1 into 1 by 4 is equal to f of 0. So f of 0 is equal to 1 plus 2 times it cancel, which is equal to, taking LCM, it becomes 3 by 2, and from our options the option is D. The solution of question number 20. The maximum value of z is equal to 2x plus y. We are taking given constraints 3x plus 5y taken as equal to 26, and 5x plus 3y is equal to 30. Now 3x plus 5y is equal to 26 can be taken as 3x upon 26, 5y upon 26 is equal to 1, and x upon 26 by 3 plus y upon 26 by 5 is equal to 1 with equation 1. The first line. Second line is 5x plus 3y equal to 30. Can be taken as divided by 30 on both sides. Okay, we are getting 30 upon 30. Here it is x upon 6 divided by 5, here 10 times is equal to 1. This is our second line. So by taking the graph of first and two lines 1 and 2, the first line is in the form of 26 by 3, 26 by 5, whose intercepts. Second line is intercepts are 6 and 10. So second line we are taking here 6 x intercept, y intercept 10, then this is our line 6 comma 0, and y axis x0 y10. This is the line second. Now the first line 26 upon 3, 26 upon 5, x intercept 26 upon 3, 26 upon 3, whose value is, we are taking as, this value is nearly 3, we have to divide it, then 3 8s are 8 point something, so it comes after the a, 6 comma 0, 26 upon 3. Similarly, second y coordinate 26 by 5, it comes 5 point something, it comes to, here it is, below 10, 26 upon 5. So our first line can be taken as this is. So common reason is, here intersection point you take as a P, okay, a 6 comma 0 and b 0 comma 10, and it is our origin. O. Now you find out the p value by solving 1 and 2. Solving 1 and 2. Equation 1 and equation 2. So equation 1 is 3x plus 5y is equal to 26. 3x plus 5y is equal to 26. Equation 2 is 5x plus 3y is equal to 30. 5x plus 3y is equal to 30. Now by solving 1 and 2, x is equal to 9 by 2 and y is equal to 5 by 2. Therefore P point is 9 by 2 comma 5 by 2. By substituting our corner values in Z is equal to 2x plus y, Z is equal to 2x plus y, origin 0 comma 0, then Z is equal to 2 into 0 plus y into 0. Next P point we have 9 by 2 comma 5 by 2, that is 2 into 9 by 2 plus y is 5 by 2. So how much? 9 into 2 18 plus 5 23 upon 2. Similarly corner value another one 0 comma 26 by 5, 0 comma 26 by 5, 0 comma 26 by 5. You substitute in the Z, 2 into, this is our Z, x place में 0 plus y बोले तो 26 upon 5. So 26 by 5 is the remaining. Another corner value is 26 by 3 comma 0. So a 6 comma 0, that is 2 into, in place of x 6 plus y is equal to 0, so 12. From all these four values, the maximum value of z is equal to 12. From the options, it is A. Solution of question number 21. So given problem, if A bar, B bar, C bar are mutually perpendicular vectors having magnitudes 1, 2, 3 respectively. Perpendicular mutually and magnitudes 1, 2, 3. Then A bar perpendicular to B bar, then A dot B is equal to 0, B bar perpendicular to C bar, then B dot C is equal to 0, C bar perpendicular to A bar, then C dot A is equal to 0, and also given A bar magnitude 1, B bar magnitude 2, C bar magnitude 3. So then we find out the box of a bar plus b bar plus c bar, b minus a, c. Now this can be taken as mod of a bar, b bar, c bar, coefficients. What do you have? 1, 1, 1, first vector. Second vector, a bar coefficient, minus 1, b bar coefficient, plus 1, and c bar coefficient, 0. Third vector, c bar, its coefficients, a bar 0, b bar 0, c bar is 1. And you multiplied by box ABC. Now you find out the data of this. We are taking plus, minus, plus. Now plus 1 into this row and this particular column will be cancelled. We have then plus 1 into remaining determinant, that is 1 into 1 minus 0 into 0. Similarly, minus 1 into its particular row and column we have to cancel. Now the column is this is. Now then minus 1 into, we are getting minus 1 into 1 and minus 0. Similarly, plus 1 into, here this particular column we have to cancel, then minus 1 into 0, minus 0. Now you multiplied by box ABC. Now we have 1 multiplied, minus into minus, plus 1, and here it is 0. So 2 into box ABC. This box ABC can be taken as a bar dot b cross c. Okay, now this 2 into this a dot b cross c, we are getting the formula mod a into mod b cross c into dot product. That is what we are taking, a dot b is mod a mod b dot product, cos we are taking angle between a bar b cross c. Now 2 into, mod a ka value. What is the mod a is given? 1. And mod b cross c ka form mod b mod c into sine of the angle between b comma c, and multiplied by cos of a comma b cross c. Now we see the angles. So 2 into, here mod b is equal to 2 and mod c is equal to 3, and sine of b and c are perpendicular, the angle between them 90, and cos of, here b cross c is perpendicular to bc and a is perpendicular to them, between the angle is 0. So 4 into 3 is 12, sine 90 it is 1, and cos 0 is also 1. So total value we are getting as a what? 12 by our options C is our answer. Now the solution of question number 22. If the points P point 4, 5, x, Q is 3, y, 4, and R is 5, 8, 0 are collinear. Okay, then the value of x plus y. So here PQ are collinear. Now we are finding by DRS. The DRS of PQ, the distance between P and Q and the difference between P and Q is 3 minus 4 PQ difference, and y minus 5, and similarly 4 minus x. So what are getting? 3 minus 4 minus 1, y minus 5, 4 minus x. Similarly, DRS of PR, P is 4, 5 x, and R is 580. Now we are getting 5 minus 4, F4 minus 5. We have to find out. Now 5 minus 4 and 8 minus 5 from P and R, and 0 minus X. Okay, now here it is 5 minus 4, which is 1, 8 minus 5, which is 3, and 0 minus X. Here it is minus X. Now when they are collinear, their ratios DRS of PQ and PR, which are proportional to each other, that is minus 1 upon 1 is equal to y minus 5 upon 3, which is equal to 4 minus x upon minus x. So comparing or equaling these both, so minus 1 is equal to y minus 5 upon 3. Similarly, minus 1 is equal to 4 minus x upon minus x. Okay, now minus 3 is equal to y minus 5, or y is equal to 5 minus 3, which is 2. Here cross multiplication, x is equal to 4 minus x. Yeah, 2x is equal to 4 and x is equal to 2. Now what do you have to find out here? X plus y. Now therefore x plus y is equal to x is equal to 2, y is equal to 2, which is equal to 4. Therefore our option is D. The solution of question number 23. Solution of question number 23. So if the slope of one of the lines given by ax square plus 2hxy plus by square is equal to 0, or in the is 2 times the other, then we have to find out the condition. Here slopes are in 2 times, then the ratio of the slopes, is 1:2. We know ratio of the slopes m is to n. Then we have relation m plus n whole square into AB is equal to 4mn h square. This is when our slopes are in the ratio m is to n, the condition where m is equal to 1, n is equal to 2. We are substituting 1 plus 2 whole square. A place में a only, and b is b only, and h is h only. So 4 into m is equal to 1, n is equal to 2, h is same as it is. Then 3 square, 9ab, which is equal to 8h square. So what are getting? 8h square is equal to 9ab, be the our condition. So our option is A. Solution of question 24. Here the question is given as a wrong question. The solution of question number 25. The negation of the statement getting above 95% marks is a necessary condition for Hema to get the admission in good college. Now we are taking the first statement, is Hema get admission in good college. Hema gets admission in good college. Now second statement we taken as getting above 95% marks. Getting above 95%. Okay, now it's negation. If this given statement is P necessary condition, P given statement is P implies Q. Now it's negation. Now it's negation. We are taking as a water. Hammer does not get above 95%. That is negation of P, and what we have, she gets admission in good college, that is Q. Therefore the option will be B. The solution of question number 26. The given problem is cos 1, cos 2, cos 3 and so on, cos 179. So between them, in this product, cos 1, cos 2, cos 3, cos 90 and so on, cos 179. Now here in this cos 1, cos 2, cos 3, the cos 90 value is 0 and so on, cos 179. So the total product is become the what? 0. Now the option is A. Now the solution of question number 27. Given that the planes x minus cy minus bz is equal to 0 and cx minus y plus az is equal to 0, bx plus ay minus z is equal to 0 passes through a straight line. These three planes are passes through a line, then they are coplanar. These three planes are called as coplanar. Now the coplanar condition is the determinant of the coefficients, where x coefficient is 1 and y coefficient is minus c and z coefficient is minus b. And in second plane, x coefficient is c and y coefficient is minus 1 and z coefficient is a. And in third plane, the x coefficient is b, y coefficient is a and z coefficient is minus 1, whose determinant value is equal to 0. By solving this, we are finding the condition of a square plus b square plus c square value. Now you simplify this by using determinant method. That is, we are taking plus 1 minus of minus c and plus of minus b. The sign will be changed. Then what we have to, the value of the determinant is plus 1 of minus plus 1 minus a square, next minus of minus plus c of minus c minus ab plus of minus b of ac minus of minus plus b, which is equal to 0. Now simplify this. We have 1 minus a square minus c square minus of minus plus abc, similarly minus abc and minus b square, which is equal to 0. Then minus a square you take that side, plus a square, b square also you take, c square also you take that sides. Then what is the remaining in this side? Plus 1 and minus abc, that is minus 2abc. Now the solution is option C. The solution of question number 28. The point of intersection of lines are represented by x square minus y square plus x plus 3y minus 2 is equal to 0. Its intersection point we find by using partial differentiation. Partial differentiation with respect to x. Okay, now we x square derivative 2x, y square be the constant and x ka derivative 1 and y be the constant, 2 be the constant, which is equal to 0. Then x is equal to minus 1 by 2. Similarly, partial differentiation with respect to y, partial differentiation with respect to y. Now here x we are taking as a constant, so x square ka derivative 0 and y square ka derivative minus 2y, x ka derivative 0 plus 3 into derivative of y is 1 and minus 2 constant derivative is equal to 0. Now minus 2y is equal to minus 3, then y is equal to 3 upon 2. Now the point of intersection where x is equal to minus 1 by 2 and y is equal to 3 by 2. So our option is C. Now the solution of question number 29. Here given that a die is rolled, if capital X denotes the number of positive divisors of the outcomes, then the range of the random variable capital X. If a die is rolled, suppose the outcomes is 1, then its positive number of positive divisors is also 1. 1 into 1 is 1. If outcome is 2, the number of positive divisors 1 into 2, that is 1 and 2 are the positive divisors, 2 positive divisors. Similarly, outcome is 3, then 1 into 3, 1 comma 3, that is 2 positive divisors. Next 4 be the outcome, then 1 into 4 and 2 into 2. Okay, so the number of positive divisors are 1, 2, 4, 3. Similarly, 5. The number of positive divisors of 5 is 1 into 5, where 2. Similarly, 6. The number of positive divisors for 6 is 1 into 6, 2 into 3. Okay, so total positive divisors are 1, 2, 3, 4. 1, 6, 2, 3. Total number of positive divisors are 4. Therefore, the range of x, capital X, can be taken as from these positive divisors 1, 2, 3, 4. So from our options, the option is B. The solution of question number 30. A die is thrown 4 times. That is, the probability of getting perfect square in at least one throw. That means we find out the probability of at least perfect square. Now which can be taken as 1 minus none of throw having perfect square. None of throw having perfect square. That means 1 minus, none of them having perfect square. That means on one die we have perfect squares are, we have 4 and 1 are the perfect squares. Okay, we remove this, then remaining none of the perfect squares are 4 out of 6 chances of a die on one throw. On second throw 4 by 6, on third throw, and similarly for fourth throw. So 1 minus, it can be taken as 2 2s are, 2 3s are. Similarly for all 4. So 1 minus, you multiply this 16, 2 you multiplied by 4 times. Now 3 you multiplied by 4 times. that is 81. Okay, now we simplify, then 81 minus 16 upon 81. Now we are after simplifying, we are getting 65 upon 81. So now the option is B. Now the solution of question number 31. Now given problem is integration of 0 to pi by 4 x into secant square x dx. By UV method, the product of the functions u we are taking as a x and v we are taking as a secant square. Okay, so then we are applying our formula u into integration of v, that is secant square x dx, and whose limits are 0 to pi by 4 minus integration of 0 to pi by 4. Now derivative of u, here u is x, and again integration of v secant square x dx. Now simplify this, x into integration of secant square is tan x, okay, whose limits are 0 to pi by 4 minus here integration of derivative of x, that is 1, and integration of secant square x is tan x, whose limits are 0 to pi by 4. Now we are substituting the upper limit in place of x, pi by 4 tan 45 x equal to. Now the lower limit x is equal to 0 we are taking, it becomes 0. Now we have to integrate of tan x, that is log of secant x, whose limits are 0 to pi by 4. So here pi by 4 into tan 45 is 1 minus 0, and log secant x we are applying the limits. The upper limit in place of x is pi by 4 minus the lower limit log of secant 0. So pi by 4 minus log secant 45, that is now where cos 45 1 by root 2 and secant 45 is we have root 2, it's the reciprocal of cos, and cos 0 is 1, cos 0 is 1, and secant 0 it's the reciprocal, that is also 1, log 1. So pi by 4 minus log root 2 and minus of minus plus, but log 1 is equal to 0. Therefore, from our given options, the answer is B. The solution of question number 32. In triangle ABC with usual notations, ABC are in AP. You know, if A, B, C are in AP, so we have condition is 2B is equal to A plus C. Okay, then we find out A into cos square C by 2 plus C into cos square A by 2. By well-known formula, cos square C by 2 can be taken as 1 plus cos C upon 2 plus C into cos square A by 2 can be taken as 1 plus cos A upon 2, and by taking LCM 2, here multiply by A with 1, A plus A into cos C, A cos C plus C into 1 plus C into cos A, that is C cos A. Now by well-known formula, A into cos C plus C into cos A, you take as a one term, remaining A will be there and also C. upon 2. So you know this formula is a cos c plus c cos a, it gives the b, plus a plus c upon 2, and be given condition of AP, a plus c is equal to 2b upon 2. So what are getting, the result is 3b upon 2. That is our option C be the correct answer. The solution of question number 33. Given x is equal to e raised to theta of sine theta minus cos theta, and y is equal to e raised to theta of sine theta plus cos theta. Now we find dy by dx by parametric differentiation. Dx by d theta, x we are differentiating with respect to theta. Here we have to do u into v. Okay, so e raised to theta u, same as it is first function, second function ka derivative, derivative of sine cos, derivative of cos minus sine multiplied by minus plus sine, plus first function e power theta ka derivative, same e power theta, and second function same as it is sine minus cos. Now in these both we are getting common e raised to theta, e power theta is getting common. What is the remaining? We have cos theta plus sine theta plus sine theta अब ये आ गया फोकस, उसकी वजह से क्या चार्जिंग नहीं लग गया. By taking e power theta common, so in first term cos theta plus sin theta plus sin theta minus cos theta. E power theta is common, cos plus sine minus cos. So here minus cos plus cos will be get cancelled. So dx by d theta is e power theta into 2 sin theta. Now we comes to y. dy by d theta, we are differentiating by u v. E power theta is u and sin plus cos is equal to v. So first function same as it is. Second function v का derivative, sin derivative cos, cos का derivative minus sine. Second function e power theta derivative same as it is, and the function is sine plus cos. So this is uv form. Here also we are getting common e raised to theta, that is cos minus sine plus cos. Here sine will be get cancelled. Now dy by d theta is equal to e raised to theta into 2 cos theta. So therefore we find out dy by dx by parametric, dy by d theta in the numerator, which is 2 e power theta cos. Next dx by d theta is in denominator, which is 2 into e power theta into sine. Now theta is equal to, given that pi by 4, substitute. Theta is equal to pi by 4. Here 2 e power theta, 2 e power theta will be get cancelled. So dy by dx is equal to cos by sine. Yeah, cos 45, 1 upon root 2. Sine 45 is also 1 upon root 2, which is equal to 1 be our solution. So by our options, the option is A. The solution of question number 34. The number of solutions of sin x plus sin 3x plus sin 5x, which is equal to 0. So you take sin 5x plus sin x as a group, and sin 3x is equal to 0. Now you find out the solution in this interval, pi by 2 to 3 pi by 2. So sin c plus sin d, it can be given that 2 sin c plus d, 5x plus x, 6x by 2 into cos c minus d, 5x minus x, 4x by 2 plus sin 3x, which is equal to 0. Now 2 into sin 3x into cos 4x and sin 3x is equal to 0. Now sin 3x we are getting common in both. Then remaining is 2 into cos 2x plus 1 is equal to 0. Now you know the product of the functions is equal to 0, then sin 3x is equal to 0. Similarly 2 cos 2x plus 1 is equal to 0. Okay, sin theta is equal to 0, then theta is equal to n pi with the general solution, and here cos 2x is equal to minus 1 by 2. Where cos theta is equal to minus 1 by 2, cos value in terms of negative. It is in second quadrant, where in second quadrant this value can be taken as 180 minus what 1 by 2 cos value is 60, that is 120. Now 120 can be taken as cos 120. So 3x, x is equal to here n pi by 3 for n belongs to z. Here 2x is equal to 120, and the general solution is of cos is 2x is equal to 2n pi plus or minus alpha, alpha means 120, and x is equal to n pi plus or minus 60. Now substituting n belongs to z values, then x is equal to n equal to 1 we are substituting pi by 3, for n is equal to 1, for n is equal to 2 we are substituting, that is 2 pi by 3, and n is equal to 3 we are substituting, n is equal to 3, then x is equal to 3 pi by 3. So number of solutions is equal to 3 by our options. Option is B. Now the solution of question number 35. The given problem is tan inverse 2x plus tan inverse 3x is equal to pi by 4. Now find out the value of x. Now it is in the form of tan inverse x plus tan inverse y. then it can be taken as tan inverse of x plus y upon 1 minus x into y, which is equal to pi by 4. So tan inverse of 2x plus 3x, 5x upon 1 minus 6x square, which is equal to pi by 4. Now tan inverse you take that side, then 5x upon 1 minus 6x square, that is tan, we are getting this side, it becomes the tan 45, that is equal to 1. So 5x upon 1 minus 6x square is equal to 1 by cross multiplication. 1 minus 6x square is equal to 5x. Now 6x square you take that side, it becomes plus already 5x, 1 we are getting this side minus 1. Now by taking the factors, 6x square plus 6x minus 1x minus 1 is equal to 0. Now 6x we are getting common, x plus 1, minus we are getting common, x plus 1. So the factors are x is equal to minus 1 and x is equal to 1 by 6. Okay, so x is equal to minus 1. If x is equal to minus 1, then result is negative. Okay, therefore x is equal to 1 by 6 be the our solution. From by our options, the answer is C. The solution of question number 36. Given matrix A is equal to 1, 2, 3, 1, 1, 5, 2, 4, 7. Now find out the value of A31 into A31 plus A32, A32, A33 into A33. You know that this gives the data. Now you find out the data of the given problem. Okay, so by taking plus, minus, plus 1 into corresponding cofactor, determinant is 7 minus 20, minus 2 into corresponding the determinant is 7 minus 10, plus 3 into its corresponding determinant is 4 minus 2. How much? 7 minus 10 minus 13 plus minus 2 into 7 minus 10 minus 3. Now 4 minus 2, 2 into 3. Here plus 6 minus 13 plus 6 plus 6, which is equal to minus 12, which is minus 1. So the given option is C. The solution of question number 37. The contrapositive of the statement, if the weather is fine, then my friends will come and we go for a picnic. Here we have two statements. First statement you take as a P, if the weather is fine. The weather is fine. And the second statement Q can be taken as my friends will come and go for a picnic. So given statement is P then Q. Now it's contrapositive. Contrapositive. Is negation of Q, then negation of P. Now by our options, negation of Q means my friends will not come my friends will not come and we do not go for picnic if the weather is not fine. So the answer is option C. The solution of question number 38. F of x is equal to, given that x upon x square plus 1. Now it is increasing function. Then find the values of x lies in. So for increasing function, f dash of x greater than 0, f dash of x we find out by using u upon v, denominator v square, v same as it is, derivative of numerator u, that is x, is 1, minus ux same as it is, denominator v x square plus 1 ka derivative 2x, which is greater than 0. Then simplify x square plus 1 minus 2x square, the denominator is positive, you take that side, it become positive, greater than 0, or 1 minus 2x square, 1 minus 2 minus 1x square is greater than 0. Now multiplied by minus, x square minus 1 less than 0. The factors are x plus 1 into x minus 1 less than 0. X roots are minus 1 and plus 1. So when the condition is less than 0, when our x value belongs to, lies between minus 1 and 1. So our option is D. Now the solution of question number 39. Given capital X is equal to the set 4 raised to n minus 3n minus 1 for n belongs to n, natural numbers. Okay. Now when n is equal to natural numbers, we start from 1, 2, 3 and so on, substituting. Then our capital X is equal to 4 raised to 1, 4 minus 3 into 1 minus 1. If you take n equal to 1, if you take n equal to 2, 4 square 16, next 3 into 2 6 minus 1. If you take n equal to 3, 4 cube 64 minus 3 into 3 9 minus 1 and so on. So capital X be the set 4 minus 4 0, 16 minus 6, 10 minus 1 9, 64 minus 10, that is 54 and so on. Similarly the given set y. Set y is given that 9 into n minus 1 for n belongs to natural numbers. Here also you substitute n is equal to 1. Then what you are getting? 9 into 1 minus 1. Similarly, n is equal to 2 and 9 into 2 minus 1. 9 into 3 minus 1. You continue this 4 minus 1. Okay, so on, this is our set y. So from set y we are getting what? 1 minus 1 9 into 0. Next 2 minus 1 1 into 9. Similarly 3 minus 1 2 into 9 18. 4 minus 1 9, that is 27. Okay, then we are getting what? 9 into 5 minus 1, which is 36. So now we find out x intersection y, the common set, that is equal to, we are getting x. So from our options the answer is A. The solution of question number 40. The given statement P and negation of P and Q. Now you know by associative law, P and negation of P and Q. P and negation of P gives false, and Q which gives false, and it is a contradiction. Therefore the option is B. The solution of question number 41. If the line y touches the curve y is equal to 4x minus 5 be the given line. So whose slope is 4, and the curve is y square is equal to ax cube plus b at the point 2 comma 3, then 7a plus 2b. The point 2 comma 3 lies on the curve. P of 2 comma 3 lies on the curve. So it's satisfying the curve. X is equal to 2, y equal to 3. You substitute in our equation 2. So y is equal to 3, we are substituting 3 square, and x equal to 2, we are substituting it is 2 cube plus b. Then 9 is equal to 8a plus b. Now this is our equation number 3. So you know the slope of the line. The line become the tangent of the given curve. So the slope we are finding by differentiating the curve. The curve equation is y square is equal to ax cube plus b. Now differentiate 2y dy by dx is equal to a into x cube का derivative 3x square, b का derivative 0, and dy by dx is equal to 3ax square upon 2y. At the point 2 comma 3 we are substituting. X equal to 2 we are taking, then 3a into 4. Y is equal to 3 we are taking. Now by simplification, the slope is tangent slope. We are getting as a 2a, where 3 get cancelled 2 times. So both the slopes of the lines, one is 2a and another slope is 4. Slopes are equal. Then we have a is equal to 2. Now we want to find out b value, that is from the equation 3. From 3, 8a plus b is equal to 9. 8a plus b is equal to 9, where a is equal to 2, 16 plus b is equal to 9, b is equal to minus 7. Now we find out 7a plus 2b value. 7 into a plus 2 into b. 7 into a is 2, 2 into b is minus 7. So the sum is what? Positive, negative. We are getting 0. So from the options, answer is A. The solution of question number 42. The sides of a rectangle are given by x equal to plus or minus a and y is equal to plus or minus b. So this is the coordinate system. X is equal to plus or minus a. We are taking a rectangle. Okay, x is equal to a and x is equal to minus a, and y is equal to b and y is equal to minus b. The equation of the circle passing through the vertices of the rectangle. The vertices of the rectangle, where here this point is where x coordinate from the origin is a and y coordinate is b, a comma b. Now the circle is passing through these vertices. Now we want to find out. So the equation of circle, whose circle center is origin 0 comma 0. Now you find out the radius. Now the radius is r is equal to OP. O to P be the radius. Now that is distance between origin and P. That is root over a square plus b square. Therefore equation of circle, we are getting from our diagram x square plus y square is equal to r square. That is root over a square plus b square whole square, where square root cancelled. Then equation of circle is x square plus y square is equal to a square plus b square. From the given options, answer is B. The solution of question number 43. The minimum value of the function. Given function is f of x is equal to x into log x. Okay, for maxima or minima. Yeah, here we want minima. F dash of x is equal to 0. Now differentiate. U into v, first function x same as it is, second function log x का derivative 1 by x, first function x का derivative 1, second function log x same as it is. So here x will be get cancelled, 1 plus log x is equal to 0. Now log x is equal to plus 1, you take that side, minus 1, having base e, or x is equal to e raised to minus 1. Yeah, x is equal to 1 by e. So at x is equal to 1 by e, we are getting the function has minima. So f of 1 by e means x equal to 1 by e, you substitute in the function. Minimum value, for minimum value, x equal to 1 by e, next log of x plus में 1 by e. This can be taken as 1 by e log of e raised to minus 1. 1 by e minus 1 comes to coefficient, minus 1 into log e. So the solution is minus 1 by e, where log e is equal to 1. So the option is A. The solution of question number 44. Given n is equal to 10, p is equal to 0.4. Now you find out e of x square. So from this we are finding the mean. E of x is equal to np, that is 10 into 0.4. 0.4 can be taken as 4 by 10. So mean is 4. Similarly, we are taking variance. V of x, that is n into p into q, where n is 10, p is 4 by 10 and q is 6 by 10. Now here 10 get cancelled, 24 by 10, that is 2.4, variance of x. Now we know that the variance of x is equal to e of x square minus e of x whole square. We have formula. From this e of x square we want to find out. So e of x square equal to variance of x plus e of x whole square, where variance of x is 2.4 and e of x is 4 square. Now 2.4 plus 16, which is equal to 18.4. So the option is D. The solution of question number 45. The given differential equation dx by dy is equal to cos of x plus y. Now let x plus y is equal to t. Now differentiate with respect to y. Dx by dy, derivative of y is 1, dt by dy. So dx by dy is equal to dt by dy minus 1. Now substitute in the given problem. Dx by dy is dt by dy minus 1, which is equal to cos of x plus y, can be taken as t. Now dt by dy is equal to 1 plus cos t. Dt by dy is equal to 1 plus cos t, can be taken as 2 cos square t by 2. So dt by cos square t by 2, you take this side, okay, which is equal to 2 dy. Now both sides we are integrating, so 1 upon cos square can be taken as secant square p by 2 dt, which is equal to 2 into integration of 1 dy y plus c. Now, so integration of secant square tan t by 2, which is secant square can be taken as tan t by 2 and its inner derivative 1 by 2, and here 2y plus c. Now this 2 comes to coefficient, 2 tan t can be taken as x plus y by 2, okay, and which is equal to 2y plus c. Both sides 2 get cancelled, then tan of x plus y by 2 is equal to y, and c by 2 can be taken as again c. So whatever the option is, tan of x plus y by 2 is equal to y plus c, that is our option A. The solution of question number 46. Given problem, if the planes r bar dot pi minus j plus 2k plus 3 is equal to 0 and r bar dot 2i minus pj minus k minus 5 is equal to 0 include an angle. So the plane's normals, first plane normal n1 bar is pi minus a plus 2k, second plane normal n2 bar is 2i minus pj minus k. Now the given angle theta is equal to pi by 3, then formula cos theta is equal to n1 bar dot n2 bar by mod n1 into mod n2, where theta is equal to pi by 3 60, and n1 bar, that is pi minus a plus 2k dot product with 2i minus pj minus k upon mod n1 bar is mod n1 bar, this is this I j k coefficient ka squares, p square 1 square 2 square, similarly 2 square p square 1 square. Now cos pi by 3 cos 60, that is 1 upon 2. Now the dot product 2 into p, next minus 1 into minus p plus p 2 into minus 1 minus 2. Denominator we multiplied, same term root into root over cancel, then p square plus 4 plus 1. Now simplify. So 1 by 2 is equal to 3p minus 2 upon p square plus 5. By cross multiplication, what we are getting, p square plus 5 is equal to multiplied by 2 6p minus 4 by taking positive. So p square minus 6p plus 9 is equal to 0. Okay, then factors are, it is p minus 3 whole square, the value of p we want to find out. So p minus 3 whole square is equal to 0, so p is equal to 3. So by given options, the answer is D. The solution of question number 47. The order of the differential equation of all parabolas whose lattice rectum is 4a and axis parallel to the x-axis. So the equation of parabola y minus k whole square is equal to 4a into x minus h, where h comma k are parameters. So two parameters, then its order is equal to 2. So the given option is D. The solution of question number 48. Two lines are given, they are intersecting, then the value of k. So the lines are passing through the points. The two lines which are passing through the points 1, -1, 1. Second line passing through the point is 3 y minus k, okay, that is k, and z minus 0, this is 0. And similarly, which are having first line DRS, the DRS are 2, 3, 4 for first line. For second line DRS is 1, 2, 1. Then they are intersecting, then these determinant of difference of A and B, 3 minus 1, similarly k minus of minus plus 1, 0 minus 1, the DRS are 2, 3, 4 and 1, 2, 1, which is equal to 0. Now find out 2 k plus 1 minus 1, 2, 3, 4, 1, 2, 1, whose determinant is equal to 0. Then simplify by the determinant by taking plus, minus, plus. Plus 2 into the determinant is 3 minus 8 minus k plus 1 into multiplied by its determinant is 2 minus 4 minus 1 into 4 minus 3, which is equal to 0. 2 into minus 5 minus 10 minus 2 into minus plus 2k plus 2, 4 minus 3, 1 into minus 1 is equal to 0. Then 2k, 2 minus 11 minus 9, which is equal to plus 9. Then from our options, k is equal to 9 by 2. Then the option is A. The solution of question number 49. If a line makes angles 120 and 60 with the positive directions of x and z, so given angles from the problem is alpha is equal to 120 and the angle made by the line with the positive y-axis is beta and positive z-axis is gamma, that is given 60. Now we know that the cos square alpha plus cos square beta plus cos square gamma, which is equal to 1. So cos square 120 alpha is cos square beta and cos square gamma, that is 60, which is equal to 1. Now cos 120, which is in second quadrant, 180 minus 60, this value is minus 1 by 2 whole square. Cos square beta and cos 60, that is 1 by 2 whole square, which is equal to 1. So cos square beta is equal to 1 minus 1 by 4 you take this side, here also 1 by 4 you take this side. So cos square beta is equal to, we have taking 4 LCM, 4 minus 1 minus 1. So cos square beta is equal to 4 minus 2, 2 by 4, that is 1 by 2. Now cos beta is equal to plus or minus 1 upon root 2 cos beta. So the angle is beta is equal to 135. Then the option is C. Now the solution of question number 50. If L, M are 2 points whose position vectors 2a minus b and a plus 2b respectively, the position vectors of the point N which divides the line segment LM in the ratio 2:1, okay, where L can be taken as a point, it is 2 comma minus 1 and M can be taken as a point 1 comma 2. So by external division formula, N is equal to, so 2 into 1 comma 2 minus 1 into 2 comma minus 1 upon 2 minus 1. So N is equal to 2 comma 4 minus 2 comma minus 1 upon 1. N is equal to 2 minus 2 0, 4 minus of minus plus 5. In vector form, it can be taken as 5 into b bar. Therefore, from our options, the answer is C.